Good morning, boys. In this session, I am going to discuss about last topic in hydrogen lesson, intermolecular forces. Already I discussed about in type of chemical bonding, ionic bond, covalent bond and coordinate bond arises due to attractive forces between atoms. Van der Waals was the first person to propose the existence of attractive forces between atoms in inert gases, even though these are completely filled electronic configuration. These forces also exist between non-polar molecule as well as polar molecule. Due to presence of these attractive forces between the molecules are moved very close to each other. So, the attractive interaction between different molecules of the substance is called as intermolecular forces. This is one more question. What are intermolecular forces? The attractive interaction between the different molecule of the substance is called as intermolecular forces. The three major types of intermolecular forces are dipole-dipole interaction, hydrogen bonding, and the third one is van der Waals force. All these intermolecular forces are very weak forces, electrostatic forces and physical in nature. Now, in this topic, we discuss about hydrogen bonding. Let us consider these three molecules HF, H2O, NH3. Hydrogen fluoride, water molecule, ammonia. In hydrogen fluoride molecule, hydrogen form covalent bond with a fluorine atom. Sharing of electron between two atoms is nothing but covalent bond. So, here hydrogen form covalent bond with a fluorine atom. Similarly, in water molecule, two hydrogen atom form two covalent bond with a oxygen atom. In ammonia molecule, three hydrogen atom form three covalent bond with a nitrogen atom. Here nitrogen, around nitrogen 5 electrons are there. In each hydrogen 1 electron. Sharing of electron, they form 3 bond pair, nothing but covalent bond. Here 2 lone pair and single electron around oxygen. Valence electron on oxygen is 6 and hydrogen carry 1 electron. Sharing of electron between hydrogen and oxygen, they form 2 covalent bond. Here around fluorine, valence electrons are 7. Among these 7 electrons, 1 form covalent bond with a hydrogen atom. In this cases, listen, fluorine compare with hydrogen, fluorine is highly electronegative atom. That's why it attracts the shared pair of electron towards itself. That's why it carry partially negative charge on it. At the same time, hydrogen carry partially positive charge on it. This is denoted by a symbol HF, covalent bond, but highly electronegativity of fluorine atom when compared with the hydrogen, it carry partially negative charge. these carry partially positive charge. Similarly, in water molecule, compare with the hydrogen, oxygen is highly electronegative atom. That's why it attracts the shared pair of electron towards itself. That's why it carry partially negative charge. At the same time, hydrogen carry partially positive charge. This hydrogen also carry partially positive charge. That's why I write here 2 minus. Similarly, these three compare with this hydrogen atom. Nitrogen is highly electronegative atom. So it attracts the shared pair of electron towards itself. That's why it carry partially negative charge. At the same time, all these three hydrogen carry partially positive charge. So what is meaning of hydrogen bonding? Hydrogen atom covalently bonded with, you take this molecule hydrogen atom covalently bonded with a highly electronegative atom such as fluorine, oxygen and nitrogen. Then the bond is said to be polarized bond. Polarized means it carry partially positive charge and partially negative charge on fluorine atom. Then this covalent bond is referred as polar covalent bond. Then the bond is said to be polarized. So when a hydrogen atom covalently bonded with highly electronegative atom such as fluorine, oxygen and nitrogen, the bond is polarized. Due to this effect, that polarized hydrogen atom form a weak electrostatic attraction with another highly electronegative atom present in the vicinity. This interaction is called as hydrogen bonding. Usually this hydrogen bond is represented by dotted line. Okay, see that hydrogen form covalent bond with the fluorine atom. This is one molecule. I write so many hydrogen fluoride molecule here. This is one molecule, this is another molecule, this is a third molecule. So this is polarized hydrogen atom. Due to polarized hydrogen form a weak electrostatic attraction with the neighboring highly electronegative atom. Here is fluorine. So the weak electrostatic attraction between hydrogen and a neighboring fluorine atom denoted by represented by dotted line. This is called as hydrogen bonding. This interaction is called as hydrogen bonding. Clear? Now, what is the condition for effective hydrogen bonding? Here fluorine is highly electronegative than hydrogen. That's why it form hydrogen bond with a fluorine atom. Condition for, next we discuss about condition for effective hydrogen bonding. This is definition of hydrogen bonding, 3 more question. Next we discuss about conditions for effective hydrogen bonding. If you understand the concept, then all your 2 mark and 3 mark question answer is easy for you. Listen carefully. The first condition for effective hydrogen bond is highly electronegative atom. High electronegativity of atom bonded to hydrogen atom so that the bond is sufficiently polar. Second condition, small size atom bonded with hydrogen atom so that it is able to attract bonding electron pair effectively. Any atom follow these two conditions, they readily form effective hydrogen bond, strong hydrogen bond with a hydrogen atom. High electronegativity of atom bonded to hydrogen atom, then the bond is polar in nature. Small size atom bonded with a hydrogen, it is able to attract bonding electron pair effectively. If any atom with a low electronegativity value and a larger in size, dipole-dipole interaction not enough, not sufficient to form effective hydrogen bonding. Only fluorine, nitrogen, oxygen form strong hydrogen bonding with a hydrogen atom. Now, next we discuss about strength of hydrogen bonding. Next heading is strength of hydrogen bonding. Hydrogen bonding is weak force only, that is it is a electrostatic force, not a strong chemical bond similar to that of ionic bond, covalent bond and coordinate bond. Okay, the strength of hydrogen bond depends upon the high electronegativity atom to which hydrogen atom covalently bonded. Okay, so order of electronegativity among in the periodic table, which one is highly electronegativity? 17th group elements are highly electronegativity. 17th group elements are nothing but fluorine, chlorine, bromine, iodine. Even though fluorine, chlorine, bromine, iodine, so these are highly electronegativity, but these are larger in size. That's why these are not form effective hydrogen bond with a hydrogen atom. Fluorine is smaller in size, that's why it readily forms strong hydrogen bond with a hydrogen atom. Okay, now see that order of electronegativity. Next, these are your, I write a 3 point here, all these 3 are your 1 more question. Order of electronegativity. Fluorine is highly electronegative than oxygen. Oxygen is highly electronegative than nitrogen. Next, hydrogen bond strength depends upon the nature of electronegativity atom to which hydrogen covalently bonded. So, next we discuss about order of strength of hydrogen bond in the order. This is first point. Second point, strength of hydrogen bond in the order of HF. Between HF, the bond is covalent bond. It form hydrogen bond with a neighboring hydrogen atom. This is greater, like that. H covalently bonded with oxygen. It form hydrogen bond. Hydrogen bond represented by dotted line only. Next is Hn. Between hydrogen and nitrogen, the bond is covalent bond. It form hydrogen bond with a hydrogen. Next, third point, we discuss about between that is hydrogen bond is weaker than covalent bond, it is weaker than ionic bond, but hydrogen bond is stronger than dipole-dipole interaction and van der Waals force. So, what is the correct order of bond strength between different bond order? Listen. So, what about ionic bond? This is next one more question. Ionic bond stronger than covalent. in the increasing order. The strength is expressed in the increasing order. Ionic bond, covalent bond. Hydrogen bonds are weaker than covalent bond. The next one is hydrogen bonding. Next one is dipole-dipole interaction. The last one is van der Waals force. Weakest force is van der Waals force. It is present in even though it is weaker, it is present in inert gases, that is van der Waals forces. So, strength of hydrogen bond. So, based on this we discuss 3 points here. All these are your one more question. Copy this. Next we discuss about types of hydrogen bonding. Hydrogen bonding can occur with either within a molecule or between the molecule. Based on this, hydrogen bondings are further classified into two types. Now we talk about types of hydrogen bonding. There are two types of hydrogen bonding. One is intermolecular hydrogen bonding. Second one is intramolecular hydrogen bonding. We discuss these types of hydrogen bonding one by one. Now I discuss about intermolecular hydrogen bonding. Intermolecular hydrogen bonding can occur between two molecules. Then the type of hydrogen bondings are called as intermolecular hydrogen bonding. The two molecules hydrogen bonding occur between two molecules. The two molecules may be same type of molecule or different type of molecules. It may be a simple molecule or complex molecule. Now I write some example for intermolecular hydrogen bonding. Inter means between. Hydrogen bonding. Simple definition only. What is the definition for hydrogen bonding? Intermolecular hydrogen bonding. Hydrogen bonding formed between two molecules. That's all definition. These two molecules are either same type or different types. Let us consider alcohol. What is the general formula for alcohol? You know that it is an organic compound. Generally R is alkyl group or aryl group or alkyl group. We discussed in detail in our organic lesson. ROH. It is referred as alcohol. So now I take many alcohols. I write ROH. I write another ROH. I take 3 only here, OH. So here hydrogen atom covalently bonded with the oxygen atom in this alcohol. Like that, in this alcohol, this hydrogen atom covalently bonded with the oxygen. Now this covalently bonded, compare with the oxygen, hydrogen is electropositive one, oxygen is highly electronegative one. That's why this second molecule contains this oxygen form a hydrogen bond with this hydrogen atom. First molecule contains hydrogen. This forms a hydrogen bond with a second oxygen atom present in a alcohol. Like this, the second hydrogen atom forms a hydrogen bond with a third alcohol. Here, similar, that is hydrogen bond formed between two molecules or many molecules. So, same type of molecules form a hydrogen bond like that. Instead of this alcohol, if I write here H, what is this formula? It is water. Yes or no? Yes. So, it is water. So, water also form intermolecular hydrogen bond. It forms strong intermolecular hydrogen bond. That's why it exists in the form of liquid. Okay. So, what is the reason it exists in the form of liquid? Means due to presence of intermolecular hydrogen bond. Not only it is here also hydrogen bonding formed between two water molecules or many water molecules. Now, hydrogen bonding also formed between two different molecules, same molecules or two different molecules. I take alcohol and water. Alcohol general formula ROH, water formula HOH. Again I write one more alcohol. So here this hydrogen atom form hydrogen bond with a oxygen atom of water molecule. Like that, hydrogen atom present in water molecule form hydrogen bond with a alcohol molecule. So between molecules the bond formed is referred as intermolecular hydrogen bonding. So this occur either in same type of molecule or different type of molecule. Not only between two molecules, they can occur between any number of molecules as long as hydrogen donor and acceptors are present in a position. So these are some examples for intermolecular hydrogen bond. Next we discuss about intramolecular hydrogen bond. Very simple topic this one, but your exam point of view this is very important topic. Everything is your 2 mark question and 3 mark question and so many 1 mark questions asked in that part. Next we discuss about intramolecular hydrogen bonding. This type of hydrogen bonding occur within a molecule. Same molecule the hydrogen bond is formed, that is called as intramolecular hydrogen bonding. Intramolecular hydrogen bonding are these occur within a molecule. The molecule which contains hydrogen, oxygen, nitrogen and fluorine, that compounds only undergoes intramolecular hydrogen bonding. That is very important. Highly electronegative atoms are 3 only. What are that one? Fluorine, oxygen and nitrogen. So the compound which contains nitrogen or oxygen or fluorine along with the hydrogen, they form intramolecular hydrogen bonding in the same molecule, that are called as intramolecular hydrogen bonding. Usually intramolecular hydrogen bondings are called as chelation. It is frequently occur in organic compound. Chelation means complex compound. When 5-membered or 6-membered compounds are available in organic compound, they readily form a intramolecular hydrogen bonding. Now example for intramolecular hydrogen bonding. This is structure of benzene. If I write OH, then it is referred as phenol. Now, for my convenience, I write this structure like this. OH. If I write, this is a functional group in this phenol structure. Adjacent position I write one more group, NO2. Adjacent position to the functional group is referred as ortho position. This position is called as ortho. Next position is referred as meta. Next position is called as para. We discuss everything in your organic lesson. Listen carefully this point. Phenol, benzene and OH. OH is a functional group. Adjacent position is referred as ortho. For OH, this is adjacent position, this is also adjacent position. Both are called as ortho position. In ortho position, I write nitro group. NO2 means this is nothing but nitro group. So, what is the name of this compound means? It is called as ortho nitrophenol. Ortho, I mentioned O. O indicate that ortho. If I write M means that is meta. I write P means that indicate para position. The structure of ortho nitrophenol. Now, 6-member ring structure along with the functional group OH and one more functional group is NO2. NO2 I write N. Valency here for nitrogen is 3, oxygen valency 2. That's why I put double bond with nitrogen and oxygen. I put double bond between them, and this is called as coordinate covalent bond. If I put arrow mark, it is called as coordinate covalent bond. So, here highly electronegative oxygen atom is available in nitro group. At the same time in phenol, hydrogen is there. So, it is highly electronegative atom, here hydrogen. The covalently bonded hydrogen atom form hydrogen bond with a neighboring highly electronegative atom within the molecule. That's why this is intramolecular hydrogen bonding. Similarly, another example, I write benzene structure. If I write here OH, this is called as phenol. Adjacent position, I write CHO. This is aldehyde. CHO means functional group name is aldehyde. General name, commonly these are called as salicylic aldehyde. Here in ortho position hydroxy group is there. That's why up to this part is called as benzaldehyde. This is ortho. So, ortho means hydroxy group. Here compared to OH and CHO, functional group is dominate here aldehyde. That's why it is considered as substituent. So, it is referred as ortho-hydroxybenzaldehyde. Another name of salicylic aldehyde is ortho-hydroxybenzaldehyde. Adjacent position. Functional group adjacent position, one more substituent is present means that is indicated by ortho. So, here this can be represented as OH CHO. I write carbon valency 4, CH, hydrogen valency 1, that's why single bond, oxygen valency 2, that's why between carbon and oxygen I put double bond, carbon valency 4, 1, 2, 3, 4. Here oxygen is highly electronegative atom. This hydrogen atom form covalent bond with a oxygen. Now this hydrogen atom, polarized hydrogen atom form hydrogen bond, weak electrostatic attraction with a neighboring highly electronegative atom, here is oxygen. So, within the molecule hydrogen bond is formed, then this is referred as intramolecular hydrogen bond. Similarly, salicylic acid, another example, salicylic acid, same structure. Acid means the functional group is C double bond O, OH. Here I write OH. So, this is up to this part is referred as benzoic acid. Substituent is hydroxy group. Then what is the name of this compound? This compound is called as ortho-hydroxy benzoic acid. Otherwise, it is called as salicylic acid. Either you call this one in the name of salicylic acid or ortho-hydroxy benzoic acid. So, here they form what type of bond? intermolecular hydrogen bond or intramolecular hydrogen bond? Here it form intramolecular hydrogen bond. Intramolecular hydrogen bond means within the molecule it form hydrogen bond with a highly electronegative atom. So, all these three compound form cyclic compound. Here intermolecular hydrogen bonds are occur in open structure, but in intramolecular they form cyclic compound. This type of cyclic compounds are otherwise referred as chelating compound. These are mainly occur either 5-membered or 6-membered organic compounds. What are the main difference between this intermolecular hydrogen bond and the intramolecular hydrogen bond? That is your 3-mark question. Difference between inter and intramolecular hydrogen bond. Difference between inter and intramolecular hydrogen bond. Hydrogen bonding. Another one is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Intermolecular hydrogen bond occur between two molecules. Many times I mentioned that word, between molecules. Intramolecular hydrogen bonding occur within the molecule. Same molecule. Intermolecular hydrogen bonding can occur any number of molecules as long as any number of molecules either same type or different type, either like or unlike molecule. Intramolecular hydrogen bondings are otherwise called as chelation. Chelation means ring formation complex compound. Important point is melting point and boiling point of intermolecular hydrogen bonds are high. Usually melting point and boiling point of intramolecular hydrogen bond formed molecules are low values. Readily soluble in water. Readily soluble in water. Solubility decreases. Solubility decreases in intramolecular hydrogen bond. Example for this one: alcohol, water, ammonia, HF. These are some example for intermolecular hydrogen bonding. Intramolecular hydrogen bonding, I wrote 3 examples there. They are nothing but orthonitrophenol, salicylaldehyde, salicylic acid. These are the main difference between intermolecular and intramolecular hydrogen bonding. Due to presence of this intermolecular and intramolecular hydrogen bond in a given compound, it affects the many physical properties such as solubility, melting point, boiling point, viscosity, density, heat of vaporization, heat of fusion, etc. I will discuss here some example. How this affect melting point and boiling point. Solubility. Listen, let us consider these two examples. At room temperature, HF is in liquid state, but HCl is gaseous form. Why? This kind of question may be your 2 mark question. HF exists in liquid state, but HCl in gaseous state. Why? Give reason. Like that they ask. What is the reason? HF at room temperature, they form intermolecular hydrogen bonding. Even though chlorine is highly electronegative than hydrogen, it is larger in size. Condition is smaller sized with high electronegativity atom only form hydrogen bond. But here, even though chlorine possesses high electronegativity value, but it is bigger in size, that's why it cannot form either intramolecular or intermolecular hydrogen bond. That's why it is exists in the form of gas, it is exists in the form of liquid in room temperature. Single answer, you get 2 mark. Presence of intermolecular hydrogen bond in HF, it is present in the form of liquid, 1 mark. Absence of intermolecular hydrogen bond in HCl, it is exists in the form of gas. Another example like that, H2O exists in the form of liquid, whereas H2S. Here also hydrogen, electronegative element only, but it is bigger in size. What is your answer? Water form strong intermolecular hydrogen bond. That's why it is present in the form of liquid. Due to absence of hydrogen bond in hydrogen sulfide, it is exists in the form of gas. Next, boiling point and melting point. Boiling point of monocarboxylic acids are more than expected value. What is the reason? General formula for monocarboxylic acids are RCOOH. Monocarboxylic acid. Carboxylic acid group is here only one. That's why these are referred as monocarboxylic acid. These are generally referred as RC double bond OH. This is one molecule. I write one more molecule RC double bond OH. Here highly electronegative oxygen atom form hydrogen bond with this hydrogen. Similarly here this oxygen form hydrogen. That's why dicarboxylic acid exists in the form of dimer. So its melting point as well as boiling point are higher than expected values. Okay, due to what type? Between carboxylic acid. That's why this is example for intermolecular hydrogen bonding. What type of hydrogen bond is occur in monocarboxylic acid? If you understand the basic, then only you answer for all your 1 mark question. So here what type of hydrogen bond is available between molecule? That's why the type of hydrogen bond is nothing but intermolecular hydrogen bonding. Alcohol, let us consider this example. I discuss about melting point and boiling point here, and the solubility. I explain about physical nature of these substances. Next I discuss about solubility. You consider ethanol, functional group is alcohol, and a dimethyl ether, formula is CH3O CH3. So here also 2 hydrogen is there, 6 hydrogen is there, 1 oxygen is there. Here also same only there. So molecular weight of alcohol and dimethyl ether are almost equal. However, the boiling point of ethanol is higher than dimethyl ether. What is the reason? Means, listen, alcohol C2H5 or OH. I write one more molecule OH. One more molecule C2H5OH. Now it form what bond? Intermolecular hydrogen bond. Between ethanol, intermolecular hydrogen bond is occur. That's why it possesses high boiling point than dimethyl ether. I write this one. CH3O CH3. Another molecule I write CH3O CH3. Here there is no hydrogen. Okay, that's why here absence of hydrogen. Absence of hydrogen, hydrogen bonding is absence. That's why boiling point of this is lower than. For breaking this bond, we need more energy. That type of hydrogen bonding is absent here, so that it possesses low boiling point. Here they form a intermolecular hydrogen bond. Effectively, for breaking these so many hydrogen bond, we need more energy. That's why boiling point of this ethanol is higher than dimethyl ether due to presence of intermolecular hydrogen bonding. Like that, you consider orthonitro. Next, solubility. It is readily soluble in water. It is gaseous state. Diethyl ether is volatile gas. It is liquid in state. What is the answer for this one also? Nothing but due to presence of intermolecular hydrogen bonding in ethanol, absence of hydrogen bonding in dimethyl ether. So everything is based on presence or absence of hydrogen bond in it. Next, it is readily soluble in water. Alcohol, ethanol readily soluble. Lower member of alcohols are readily soluble in water, but dimethyl ether insoluble in water. Why? Nothing but with a water molecule. With a water molecule it form intermolecular hydrogen bond. With a water molecule it does not form intermolecular hydrogen bond. That's why it is insoluble in ether, that is water. It is soluble in water. Next, like that, so many examples are there. All are reasoning question, your exam point of view. Listen carefully. So, like that, intermolecular hydrogen bond not only present in simple molecule, it also present in many complex compounds such as protein, carbohydrate, DNA, like that. Next, we discuss about structure of water. Structure of water already we discussed, it is V shape. So, I write water molecule also form hydrogen bond with one another. Each oxygen atom in water molecule surrounded by tetrahedrally by 4 water molecule. Listen, one water molecule I write, another water molecule I write H covalent bond between 2 hydrogen and oxygen in water molecule. 2 covalent bond is there. Here also 2 covalent bond. I write HO. Here 2 covalent bond. I write 3 water molecule. We know very well oxygen is highly electronegative than hydrogen. So, it appear partially negative charge. It appear partially positive charge. Like that. Here also it appear positive charge. This appear negative charge. 2 plus, that's why here I write 2. Otherwise simply I represented as del minus, partially del plus, like that. Okay. Now, oxygen highly electronegative atom form 2 covalent bond with a 2 hydrogen atom in water molecule. Due to high electronegativity of oxygen atom, it form, listen carefully, it form 2 hydrogen bond. Highly electronegativity of oxygen atom form 2 hydrogen bond. This is 1, this is 1. So, 2 hydrogen bond with a 2 hydrogen atom present in 2 water molecule, from which we can understand that each oxygen atom surrounded by tetrahedrally by 4 water molecule. That's why water also exists in the form of ice. Here 2 hydrogen atom as well as 2 lone pair on oxygen atom. on oxygen atom, it attracts the shared pair of electron towards itself, that is why. So, it form a orderly 3-dimensional structure in ice, that is why the ice look like a, see that, this structure of ice look like a open cage like structure, that is why its density is low, that is why these ice molecules are float on water. What is its structure? Open cage like structure. It form orderly 3-dimensional structure due to presence of 2 hydrogen atom and 2 lone pair of electrons on each oxygen atom of water molecule. This arrangement form a 3-dimensional structure in ice, that is why all water molecules are very close together, that is why it possesses low density than liquid water, that is why water molecules are float on water at 0 degree Celsius. Okay, next we discuss about not only importance of hydrogen bonding, life would have been seen impossible without liquid water, which is result of intermolecular hydrogen bond, cotton, synthetic fibers and wood material, all are consist of many strong hydrogen bond, that is why these have its own rigidity and tensile strength, and also hydrogen bonding play important role in food materials such as carbohydrate as well as protein.